Gallbladder, good for what? Biostorage. Biostorage. Meaning, if you eat a lot of fatty food, you need a lot of bile. Bile will be secreted directly out of your liver into your common bile duct eventually and into the duodenum. But if you need extra bile, then gallbladder will provide it. So gallbladder has to have a duct, right? In order to get the bile into the duodenum, it has to have a duct. And this green one here is your cystic duct. Cystic duct belongs to the gallbladder.
I have a question. What happens when they take out your gallbladder?
To what?
When they take out your gallbladder?
You still have your liver, and liver produce bile. So you have bile coming from the liver, but this would be enough for not very fatty foods. If you eat a lot of fatty foods and you don't have your gallbladder, then you will have problems with fat digestion. And if you don't digest fat, you will have a lot of fat in your feces. And this is described as steatorrhea.
Oh, so you're saying the liver and the gallbladder produce bile?
No! Gallbladder is just storage.
Oh, so
Mine's
why
not
does
taken
it
out.
Oh, but you won't have as much
Mine's got
bile
taken out after I had
because
my
you won't have the
daughter, so
storage
I'm
for
Then
it.
you have to be careful with your diet, making sure that you don't
You have
eat
to
at one
be a
sitting
vegetarian.
a lot of fatty foods, because then you will have a problem with fat digestion.
Oh, great.
So you have just, you have to have fat. You need fat in your diet. It's just that you have to
Eat
have
less.
that fat in many several meals a day. Like you eat a gallon of regular ice cream. Definitely.
You're right, I wish.
Just an example. Gallbladder does not produce anything.
Yeah, I heard it's like really
It's just the
not a organ you really
storage of bile. Bile is produced by liver cells. Liver produces bile.
So it's
And look,
produced in the liver and then it's absorbed into the gallbladder?
it goes. It is squeezed into the gallbladder. Because look, remember the liver lobules? There's hexagonal, tiny structure. Hexagonal meaning one corner. This is my good description. Hexagonal means 6 corners, and on each corner you have a branch of hepatic artery, you have a branch of portal vein, and you have a branch of a bile duct. Meaning liver cells make bile. The bile go into those tiny bile ducts sitting on each corner of each liver lobule, and you have millions of those liver lobules in your liver. And those tiny bile ducts, they merge together. You have
common duct.
eventually your right and your left hepatic duct. Those two merge to make common hepatic duct, and common hepatic duct merges with cystic duct. So, your liver produces all the time bile, but you don't need it in your duodenum. You don't have anything which you do in your duodenum. You haven't eaten anything here. So, that bile will go out of that common bile duct into the cystic duct, and then into your gallbladder, and you will be sitting there till you have next gallon of ice cream, regular one. Cross out left and right hepatic duct. Cross out common hepatic duct, meaning we are not going to have it.
Okay.
Leave the common bile duct, which would be the top of that green structure, and leave the cystic duct. So if you have a label here and an arrow pointing to here, then you tell me this is the cystic duct. If this is a label pointing to that, the top here, to that green duct, having the cross section here, common bile
Okay.
duct. And then we need the vessels, right? The blood supply to the liver is about renal, I already went to kidneys. This is the hepatic, and we should be.
I'm sorry, what's that?
Hepatic artery.
Hepatic artery.
Purple one is your portal vein. Red is hepatic artery. Systemic arteries are red because they carry oxygenated blood. Portal vein
It's
is
blue.
purple.
Okay.
This is part of the portal, hepatic portal circulation. And your hepatic veins, which collect blood out of the liver, they are blue. And you have, because you have right and left lobe of the liver, you have right and left hepatic vein. Right and left hepatic vein. The large lobe is your right one. So if you know that this is the right one, then you know that this is the right hepatic vein. And that has to be the left one. And they empty into inferior vena cava because that blood has to go to your heart. So inferior vena cava will give that blood to your heart. To which part of the heart? The right one, the right atrium. Because the right heart is about deoxygenated blood, the before you find exam. Did you do everything? Mm-hmm. Okay. So quickly, we have like 10 minutes. We go over kidneys, right? So let's, we have to get kidneys.
The model.
Yeah.
Well, I mean, she wanted us to know it, that's why.
We will do review, obviously, as you know, on Monday. We have all the time, and we will do the review for the final lab exam. And
We're going to do it in here or in the regular class?
no, regular class. Because somebody has here, I think, a session. Because if not, then
On Mondays. Yeah.
look at those. Okay. Kidney, never confuse those 3 layers surrounding, 3 layers of tissue surrounding the kidneys. Fibrous capsule is not on the list. Then adipose capsule and urinary fascia, not on the list. Is this a review for your multiple choice question? And then you have 3 regions of kidney. The first one, which is directly under that renal capsule. This is all the good protection against infections. And that first one is your renal cortex. So a label here with arrow pointing in both directions. Your answer is renal cortex, not just cortex, renal cortex. And a label here, rectangular, with arrows pointing again in both directions. This is your medulla.
So, but what about the lobe? Like, I've seen you do that before. I didn't hear you mention the lobe. Like, you'll say pyramid or
Yeah.
or the medulla.
We have a lobe of, on the other. Just a second. We need to actually, this is a little bit different from the other.
I like the other one better.
No, let me
Are you
take
going to use the other model instead of this one?
Yeah, let me take a look because I think the other is a little bit different.
Yeah, don't use
Just let me when you put on YouTube stuff.
Alright. We're waiting on the other model.
This one is better. Because it has what Barbara have just asked about. This is a kidney lobe. It has cortex, which belongs to renal cortex, fragment of the renal cortex, and it has a fragment of medulla, meaning one of those pyramids. So if we go back to here, this is your cortex, same situation like on the other. This is your medulla, and this is your pelvis, and so you have those 3 regions. Cortex, medulla, renal pelvis. Cortex is about renal corpuscles, filtration. Pyramids are about straight parts of renal tubules. A lot of collecting tubules are here. Some of those look off-handly, they even put them here. And urine is made in those renal tubules. So, between, this is pyramid. So a label here, a pyramid. On any of those, you tell me this is the pyramid. We have columns, meaning a little bit of that cortex moves between the pyramids. This is one of renal columns. It is like a column, see? And this is another one. And then urine is made, and those collecting duct collect urine, and it has to be caught by some structure. So, urine is secreted out of collecting tubules, which they have openings, they are tubules, they have openings, and those openings are located on that structure. This is the renal papilla. It looks like papilla, tiny projection. So, renal papilla, each renal papilla is related to one minor calyx.
Okay.
Calyces, plural, calyx, singular. So, so if you have a label like here, then you see it is related to a pyramid. So it has to be minor. And why else it has to be minor? Because minor calyces merge to provide even bigger ways for urine to be excreted eventually into the ureter. Because that urine will go out of those minor calyces into the major calyces. So this is the major one. Somebody put it that in here. So I might put that label right there if I ask you about the major calyces. And you know this is a major one because this is about 1, 2, 3 minor